Hi, it's Ben here from EyeSkills, and I just wanted to do a quick catch up with what I've been up to while I've been on holiday. So the basic idea of all this is, shouldn't the community of people with strabismus and amblyopia actually have their own tools, stuff from the community, by the community, for the community? Long term, that's probably the best thing that could happen, and long term, it means that the millions, the tens of millions of people that aren't reached by vision therapists or by ophthalmologists or people who understand what vision therapy is about have a chance, maybe even to contribute to the science. So one of the cornerstones of making this work is providing a framework for people to develop these tools and these games. And to do that, it should be specialized for amblyopia and strabismus. It should have the key components that make it simple to make these games. And amongst those pieces of the puzzle, it should help people breaking suppression. It should help people with 2D fusion, with 3D fusion, tackling vergence, accommodation, misalignment. And a lot of these things have to do with Anaglyphic cameras, VR, virtual reality headsets, the cheap ones particularly, not necessarily Oculus Rift, because so few people can afford it. And clinics can afford it. Most people can't reach clinics, and also using the cheap headsets and phone cameras for things like augmented reality. So first of all, how do we provide that framework, and how does the framework make it simple to then manage beta testers and citizen scientists? So citizen scientists will be the hopefully hundreds of thousands of people using it, giving data feedback to the scientific community, so that the scientific community can create their own tools, their own games, and we can do things like A/B testing, trying out 100,000 people with this version, 100,000 people with the other version. Because at the moment, a lot of the science is based on very small sample sizes, 12 people here, 17 people there. So one of the things I managed to get around to is to test that the out-of-the-box Unity virtual reality stuff for Oculus Rift can be reused for Google Cardboard cheap style virtual reality, where you slide your phone into a sort of a huller, a virtual reality holder for the phone, which has two lenses that you can adjust. So here we see a Brock string, and if you look through this, it's very convincing that the balls are at different distances, and you use accommodation to your eyes cross to see the ball closest to you, and they diverge as you look at the balls further away. So there's lots we can do with that, but what it showed is that you need a reasonably modern phone. Actually, if I'm not mistaken, with Android 7, and you need quite a powerful phone. So that's again not terribly accessible for the population of the world. Which took me back to the anaglyphic stuff. The anaglyphic stuff is when you have those old-fashioned 3D glasses, for example, with red and cyan. So each eye has a different color, and there are two. Those headsets are cheap. So what can we do with anaglyphic games? How can we make it simple to make those for Unity? There were Anaglyphic cameras which did it out of the box, but they haven't been developed for years. They've gone by the wayside. There's nothing that works. So I actually built this holiday a 2-mode Anaglyphic camera for Unity. It's a bit primitive. It can be dramatically improved. If you're good with Unity, please contact me. And these 2 modes are depth based a depth-based mode. So for example, on the right, you're using both eyes to see the objects at different depths. So the offset of the blue and the red cause you to perceive the object to be at different distances. It's very useful for depth training. And then there's this other sort of binocular approach, a split channel approach, where you just say, well, in this case, the cube is cyan, I'll see that with the right eye, and the sphere is red, I'll see that with the left eye. So you split up the different parts so that your brain is forced to coordinate, to fuse the two different parts. So that's the kind of the brutal approach, if you like. And that's probably most useful with sort of 2D style games. But it means that we can go from very primitive, trying to encourage the brain to do fusion, to the fine-tuning, trying to position the eyes and make the most of fusion to accurately discern depth of the relative depth of objects to one another. So yeah, one of the next spikes, a spike is like a little bit of testing that I'm going to do, is to see if I could make use of an idea I've had to use these VR headsets and cheaper phones to present to people a view of the world from their phone camera, but to control the luminance and contrast that's hitting each eye. So in the amblyopic eye, the contrast of the eye is, the ability to perceive contrast is very, very poor. The suppression reduces luminance, reduces contrast. You kind of don't know the signals there, so you rely on the one eye. But it seems from the literature that you can reduce the contrast and luminance, brightness, in the good eye, and increase contrast and luminance in the amblyopic eye, and in doing so, you overcome that threshold, you overcome the suppression, and then the person with amblyopia can use both eyes. They may then see double, diplopia, but that's the point at which they can start practicing fusion.